So we are calculating forced response. The given system is equation 1. Given system represented by differential equation. Given system represented by differential equation. It is equation 1. We are calculating forced response. In forced response, we have to make assumption output is nothing but particular integral. We will calculate particular integral. Output is nothing but k times input. Output is nothing but k times input. Already input is given in the question e power minus t u of t. Input is given in the question e power minus t u of t here. Okay. So we have to substitute this assumption in equation 1. We have to substitute this assumption in equation 1. So if you see equation 1, we are having dy of t by dt. dy of t by dt. Okay. So already y of t means k into e power minus t u of t. What I will do, I will just write it. So what I am calculating is differentiation of the previous line. Differentiation of the previous line. Differentiation will become minus k e power minus t u of t. If you do one more time differentiation, d square y of t by dt square, it will become plus k e power minus t u of t. Okay. Let this be equation 2a and this be equation 2b. 2a, 2b. I am giving input as equation number 3. I am taking input as equation number 3. But if you see equation 1, RHS, you are having dx of t by dt. Okay, already x of t is given. Which is e power minus t u of t. I am making it as equation 3. Now I am going for dx of t by dt. One time differentiation, it will become minus e power minus t u of t. This is 3a. Now I am going to use all this equation 3, 3a, 2, 2a, 2b in equation 1. In equation 1, I am going to substitute all this. So double differentiation, 2 times differentiation, equation 1. You take equation 1. This is our equation 1. This is our equation 1. First term is d square y of t by dt square. And the value is there in equation 2b. Value is there in equation 2b. Substitute. So it is k into e power minus t u of t plus 5 times. In equation 1, 5 times dy of t by dt. dy of t by dt, it is there here. So it is minus k e power minus t u of t. Then it is plus 6 y of t. So y of t, it is in equation 2. It is k times e power minus t u of t. Then RHS dx of t by dt, which is there in equation 3a. Equation 3a minus e power minus t u of t. Then plus 4 times input x of t given in the question minus t u of t. Input x of t is given in the question, equation 3. E power minus t u of t I substituted. Okay. Now if you see all the terms, you are having e power minus t u of t. Both on left side and right side, all the terms are having e power minus t u of t. So I will cancel, make a common cancellation. Okay. So k minus 5k plus 6k is on LHS. Right side it is minus 1 plus 4. Okay. I have cancelled out e power minus t u of t throughout the equation. So value will not change. So left side I have 7k minus 5k is 2k. Right side I have 3. Right side I have 3. So k value is 3 by 2, which is 1.5. Which is 1.5. Now substitute this in equation 2. Substitute this in equation 2. So particular integral, okay, is nothing but 1.5 into x of t. 1.5 into x of t, which is e power minus t u of t. E power minus t u of t. Okay. So this is about particular integral. But if you go for forced response, it is nothing but homogeneous solution plus particular integral is nothing but forced response. Okay, homogeneous solution plus particular integral is nothing but forced response. So if you see homogeneous solution in the previous session, we have completed homogeneous solution. This equation 2 we got. Equation 2 we got, okay, in homogeneous solution after finding the factors. So it is C1 e power minus 3t, C2 e power minus 2t. I will use this same question. Okay, same question. Homogeneous solution is calculated. So C1 e power minus 3t, C2 e power minus 2t, that is homogeneous. C1 e power minus 3t, C2 e power minus 2t, this is homogeneous solution, plus particular integral. Here we have calculated in the last line, particular integral is 1.5 e power minus t u of t, 1.5. So it is 1.5 e power minus t u of t. Okay, this is about forced response. This is about forced response f of t. Forced response. I am making this as equation 4. I am making this as equation 4. So forced response means input exists, and initial conditions are 0. Initial conditions are 0. Okay, so I will take initial condition 0 means I will take yf of 0 equal to 0, and one time derivation of this, one time if I make derivation, that also I will make it as 0. Okay, so in equation 4 as it is, I will put t equal to 0, and I will also derivate, okay, from equation 4. From equation 4, I will just derivate dy of f by dt. What will happen? Minus 3 c1 e power minus 3t minus 2 c2 e power minus 2t, and here derivation minus 1.5 e power minus t u of t. Okay, this be equation 4a. This be equation 4a. Now substitute the initial conditions. Substitute the initial conditions. Substitute the initial conditions in equation 4 and 4a. Okay, initial conditions initial conditions in equation 4 and 4a. Now 4 will become entirely you have to put t equal to 0. Entirely you have to put t equal to 0. So yf of 0 is nothing but c1 e power 0, c2 e power 0 plus 1.5 e power 0. U of 0 at origin step signal value is 1. Okay. This entire thing value is 0 as per initial condition. Okay. From this what you can see, c1 plus C2 plus 1.5 value is 0. Okay. Now I am going to 4a, equation 4a. You are going to take dyf of 0 by dt. The entire equation wherever in equation 4a, wherever t is there, entire 4a, you put t equal to 0. So minus 3 c1 e power 0 minus 2 c2 e power 0 minus 1.5 e power 0. Initial condition is 0. So if you simplify this, this is minus 3 c1 minus 2 c2 minus 1.5, value is 0. Okay. Now this is equation 4 and this is 4a. This is 4 and this is 4a. Now if we simplify 4 and 4a from here, okay, 4 and 4a, I will multiply equation 4 with 2. So 2c1, 2c2 plus 3 equal to 0, and this is minus 3c1 minus 2c2 minus 1.5 equal to 0. So c2 will get cancelled if you add. So here it will be minus c1 plus 1.5 equal to 0. So C1 value equal to 1.5. You use it in equation 4 again. Use it in equation 4 again if you substitute in any of one of the equation. So in equation 4 I am substituting 1.5 plus C2 plus 1.5 equal to 0. C2 value is minus 3. C2 value is minus 3. Okay, C1 value plus 1.5, C2 value minus 3. So we have to put all this in original equation 4. In original equation 4. Okay. So equation 4 is, so now the original equation 4 It is forced response. Forced response equal to C1 value 1.5 e power minus 3t, C2 value minus 3 e power minus 2t. Okay, this is homogeneous solution plus particular integral is 1.5 e power minus t u of t, e power minus t u of t. This is our final forced response. Okay, this is our final forced response after finding all the constant values. After finding all the constant values. Okay, this is about forced response. Now coming to total response. If you see total response, if you see total response, which is nothing but natural response plus forced response. Natural response plus forced response. Okay. Already we got natural response. Already we got homogeneous solution of natural response is this minus 6 e power minus 3t minus 9 e power minus 2t. Okay. So minus 6 e power minus 3t minus 9 e power minus 2t. This is our natural response. Okay. This is our natural response. And coming to forced response, what we have got just now, last line what we have got, plus 1.5 minus 3 plus 1.5. Okay, plus 1.5 minus 3 plus 1.5 e power minus 3t minus 3 e power minus 2t, then plus 1.5 e power minus t. Okay, so plus 1.5 minus 3 e power minus 3t minus 2t we have written. Last term plus 1.5 e power minus t u of t. 1.5 e power minus t u of t. Okay, so this complete is forced response and this complete is natural response. This total is total response. You can also simplify this and show. So it becomes minus 4.5 e power minus 3t, then minus 12 e power minus 2t. Okay, and last term plus 1.5. Similar terms just I am adding. Wherever similar terms are there, just I am adding. This is total response. This is total response for the given question. Okay, in continuous time, this is the total response for given question.